Alright guys, back for some more right triangle trigonometry. Today we're doing sine and cosine. Okay, the sine ratio is equal to the opposite side divided by the hypotenuse, and the cosine ratio is equal to the adjacent side divided by the hypotenuse. Remember yesterday we had tangent, which was opposite over adjacent. Okay, with so many of these, all using very similar sides, how are you going to keep those straight? Okay, we have a math saying here to help you remember those. SOHCAHTOA. SOHCAHTOA. So is S-O-H, sine, opposite hypotenuse, ca, C-A-H, cosine, adjacent hypotenuse, and toa, T for tangent, O for opposite, A for adjacent. SOHCAHTOA. Your best friend there, kids. It's going to help you remember all of them. Okay, so sine of A from angle A. Okay, we still need to label all our triangles. Alright, across the street there is going to be opposite. Okay, across from the right angle is always our hypotenuse, and that leaves this one to be adjacent. Okay, sine is opposite over hypotenuse. So from A, opposite is 4, and hypotenuse is 5. So 4/5. 4/5. Okay? What about sine of Y? From Y, my opposite is 8. My hypotenuse across from the right angle is 17. So this is 8/17. Pretty easy. All you have to do is make sure you get these sides labeled, and everything else is pretty easy after that if you can remember SOHCAHTOA. Alright? Now, these two triangles are the same. We did sine of A, and now we're going to look at cosine of B. Cosine of B. Alright, opposite, hypotenuse, and this side then is the adjacent. So from B, cosine, ca, adjacent over hypotenuse. Adjacent is 4, hypotenuse is 5. 4/5. Same answer as this one. So when you're using, okay, the same triangle, 3, 4, 5, 3, 4, 5, sine of one angle, A, will be equal to the cosine of the other angle, B. Pretty cool. Alright? Okay, again, these two triangles are the same, but now we're going from the same, we're going to be going from the same angle and see if that has any relationship at all. So cosine. Alright, so I know from up here that this is opposite, this is hypotenuse, that's adjacent. Okay? So adjacent over hypotenuse is 15/17. Okay, so no fancy like it's upside down or anything like that. It's just the opposite number. Last time it was 8/17, so this time it's going to be adjacent. It's going to be the 15/17. Alright? So really important here to be able to label the sides correctly. Opposite and hypotenuse are always the easiest two to get, I think, and then it's adjacent. And then after that, you're just going through and following the patterns. Okay, just like with tangent, when we had a degree, we're going to do the same thing here with cosine and sine when we have an angle. So here's our angle, 40 degrees. Okay, let's say I want to find x first. Okay, so from 40 degrees, x is my opposite. Oh, no right angle box there. 10 is the hypotenuse. Okay, so which one uses opposite and hypotenuse? Sine. Sine uses opposite and hypotenuse. So I want to do sine of 40 equals opposite x over hypotenuse 10. Okay, we need to get x by itself. We're going to multiply both sides by 10. Alright, so now I have 10 times the sine of 40 equals x. We're going to type that into the calculator just like we did with our tangent problems yesterday. 10 times sine, okay, sine, cosine, tangent, they're all right next to each other right there, of 40. 6.427, we'll round it to 6.4. Okay, so we got x, now we need y. Y then would be the adjacent side. Okay, so I would use adjacent. So from this point we have options. I have 2 out of the 3, so I can do a squared plus b squared equals c squared. I can do opposite over adjacent for TOA, for tangent, or I could do cosine, adjacent and hypotenuse. Lots of options. I'm going to go with the cosine. So cosine of 40 equals a over 10. We'll multiply both sides by 10. 10 times cosine of 40 should equal a. And we'll get 7.7. For our, well, I guess it wasn't a, it was y. Okay, let's quick take a peek at this one right next to it. Another one very similar. Another one very similar. Okay, so here's 52 degrees. Across from it's my opposite. Okay, another one I forgot. Right angle box. So this one is the hypotenuse. That makes this side the adjacent. Let's go with the cosine first this time. So let's do cosine of 52 equals adjacent y over hypotenuse 21. We multiply both sides by 21. So 21 times the cosine of 52 should equal y. And let's type that in. 21 times cosine of 52 degrees. And we'll have 12.9. Alright. And with our sine of 52, opposite over hypotenuse, x over 21. Again, we multiply both sides by 21. And that missing side there is 16.5. Okay, so another worksheet for today, kids. You should have a problem similar to most of those. With the 30, 60, 90 problems and the 45, 45, 90 problems, just give those a try. The front side is the most important part, as well as this section here, finding the missing sides, and then doing the sine and cosine, and then the story problems are always good. Okay, but just give 19, 20, and 21 a shot. Not worrying about right or wrong there. Alright? Again, if this was too fast for you in class, you can find it on YouTube. Just Handke Geometry, and then there should be a bunch of them that pop up. If you type in Handke Geometry and Sine, then it should be this one on top. Thanks, guys.